Today, we want to take you on an extraordinary journey to uncover a cosmic event that revolutionized astrophysics, the perfect explosion of AT2017gfo. Get ready to dive into one of the most fascinating phenomena ever observed, an event that not only captured the attention of scientists, but also changed the way we think about the universe and its evolution. An event so unique and precise that it pushed the boundaries of human knowledge, offering us an unprecedented window into the infinitely distant and the infinitely small. Imagine an explosion so precise and spectacular that it holds the keys to unlocking the deepest secrets of the cosmos. In 2017, humanity took an extraordinary step. For the first time, not only were gravitational waves detected, ripples in space-time caused by extreme cosmic events, but an accompanying electromagnetic explosion was also observed. This phenomenon, named AT2017gfo, was the result of the violent merger of two neutron stars, revealing an unprecedented spectacle that radically changed our understanding of the universe and its most extreme phenomena. Neutron stars, remnants of ancient stellar explosions, are among the most extreme and mysterious objects in the universe. These stars are so dense that a single spoonful of their matter would weigh billions of tons on Earth. Now imagine two of these ultra-dense, incredibly compact stars locked in a deadly gravitational dance. Spiraling toward each other under intense gravitational forces, they distort the surrounding space-time, drawing ever closer until they merge in a colossal explosion of energy. This catastrophic event, known as a kilonova, provided a unique opportunity to explore some of the deepest and most fascinating mysteries of the cosmos, such as the formation of chemical elements, the nature of matter under extreme conditions, and even the very structure of space-time. Until recently, kilonovae were thought to be chaotic and asymmetric events shaped by the violent forces that generate them. However, an in-depth analysis of AT2017gfo revealed something astonishing. The explosion was not irregular at all, but followed a pattern that defied expectations. Contrary to predictions, the merger produced an almost perfect sphere, a radioactive fireball expanding symmetrically in all directions. This surprising symmetry represents one of the most extraordinary discoveries in astrophysics in recent decades, with implications that could rewrite the laws governing the universe. To understand how extraordinary this discovery is, imagine trying to blow a perfectly round bubble with chewing gum. The forces at play, tensions, air resistance, imperfections in the gum, make achieving a perfectly spherical shape almost impossible. In a world dominated by chaos and imperfections, the idea that a perfect bubble could exist seems unthinkable. And yet, 140 million light-years away, the universe managed to produce an impeccable bubble of energy and matter. A feat that leaves scientists speechless, forcing them to rethink their theories and seek new models to understand how such symmetry can emerge in such an extreme environment. Scientists are trying to understand how such a violent event could generate such surprising symmetry. One leading hypothesis suggests that this extraordinary symmetry originates in the final stages of the collision between the two neutron stars. When the stars collide, they briefly form a hypermassive neutron star, which quickly collapses into a black hole. This collapse releases an enormous amount of energy that could smooth out any initial asymmetries in the explosion, contributing to the perfect symmetry observed. This process involves some of the most fundamental and mysterious forces in the universe, which physicists are still striving to fully understand. Another intriguing element involves neutrinos, almost massless particles that interact very little with ordinary matter. During the explosion of AT2017gfo, a veritable flood of neutrinos may have played a crucial role in influencing the distribution of elements produced by the merger. These particles might have contributed to the conversion of neutrons into protons and electrons, a process that fundamentally impacted the distribution of chemical elements and could explain why lighter elements were distributed so uniformly throughout the explosion. Kilonovae are not just fascinating spectacles for astronomers, but also cosmic factories of heavy elements. Gold, platinum, uranium, and other precious elements are created during these violent explosions under conditions of incredibly high temperature and pressure. However, AT2017gfo introduced a new enigma that challenges scientists' expectations. The heaviest elements did not distribute as predicted. Instead of concentrating in particular areas of the explosion, the lighter elements appeared surprisingly uniform across the kilonova. This discovery could have fundamental implications for understanding the formation of elements in the universe and might change our perspective on cosmic chemistry. The consequences of this discovery go far beyond kilonovae. If these explosions are truly spherical, they could revolutionize how we measure the expansion of the universe. Currently, astronomers use methods like the redshift of galaxies or supernovae as distance indicators. However, asymmetric explosions, such as those observed in many supernovae, can emit light unevenly, creating significant margins of error. A spherical kilonova, on the other hand, would act as a perfectly round beacon, emitting light uniformly in all directions and providing more accurate measurements. This could allow scientists to measure the distances between cosmic objects more precisely, opening new pathways for studying the universe's expansion and improving our understanding of its global structure. Derek Watson, one of the researchers involved in the study of AT2017gfo, emphasized the importance of understanding the shape of these events. An object that isn't spherical emits light differently depending on the viewing angle, he explained. A spherical explosion, however, provides much greater precision in our cosmic measurements. This could help us determine the expansion rate of the universe more accurately, solving one of the greatest enigmas of modern cosmology. This discovery raises profound questions. How can such perfect symmetry emerge from such violent chaos? Could this be a common feature of kilonovae or a unique anomaly? And if this precision exists in one of the most extreme environments imaginable, what does it tell us about the fundamental forces that govern the universe? The answers to these questions could rewrite our understanding of the universe, from the formation of chemical elements to the evolution of galaxies and even the very nature of the physical laws that regulate the cosmos. Every new discovery reminds us that the cosmos is a place of wonder and mystery, a vast expanse of surprising phenomena that continually challenge our beliefs and push us to think in new ways. The story of AT2017gfo is a perfect example of how the universe can surprise us in ways we never imagined. From the collision of two neutron stars came an explosion so precise it defied our understanding of chaos, showing us that order can emerge even in the most extreme places. Thank you for being part of this journey through science and the cosmos. If you, too, are fascinated by the wonders of space and its discoveries, subscribe to our channel to stay updated on the latest findings and to continue exploring the mysteries of the universe together.